Yes, guys, we've got an interesting looking Surds question. I'm not going to read all of that out, but when approaching a question like this, what do we actually know? Scout laser, so we can clearly see some sort of pattern. This number here, this number here, this number here, that would have been here, would have been here. They're all increasing by 1. This number here, this number here, so this number here, this number here, this number here, increasing by 1. Let's look within a surd, just one fraction. This number here is 1 less than this here and this here. Same goes here. 3, 3, 2, 2, 2, 2, 2, 2. And we've got loads of surds, and we need to rationalize them because we've got a surd on the bottom. So we're obviously not going to do this for 99 fractions, so let's do it for one general case. See what we get from here. So our general term of this sequence, we can say, is 1 over, well, let's imagine there's a 1 here because this, yeah, that makes sense, but there's 4 terms on the bottom, so we have k plus 1 multiplied by root k, so let's make this slightly bigger. K plus 1 multiplied by root k plus k times root k plus 1. And obviously we said we need to rationalize, so let's multiply this by root k plus 1 minus root k, yeah, just root k, all over root k plus 1 minus root k. So just evaluating the denominator, we've got root k plus 1, that's all good, minus root k of course. And then the denominator on the other hand, well, that shouldn't be too hard to expand, so we have k plus 1 and then times root k plus 1, so we can bring that all into one surd. K times k plus 1, that's just the first out of 4. Now let's do k plus 1 times root k multiplied by minus root k, so that's minus k times k plus 1. Now onto k root k plus 1 multiplied by k times k plus 1, that's plus k. See, the square root just cancels, so we have k times k plus 1. Finally, k times root k plus 1 minus root k. Of course, this is long. It's just k. Oh god, surds combine. That's not working. K times k plus 1. Okay. Immediately, what do we notice? Well, these two terms can cancel since they're just the same. And these other two terms on the denominator, well, what have they got in common? They've got root k. Okay, so they've got these two terms in common. So we can factorize that out. So let me just rewrite this fraction. Root k plus 1 minus root k. So on the bottom we said we were factoring out this surd. And then we're obviously left with k plus 1 minus k on the inside. That bracket's just easy to evaluate. That's simply 1. So our denominator becomes root k times k plus 1. Can we simplify this further? I believe we can. So if we split this fraction up, root k plus 1 all over root k. Notice how I'm splitting the surd on the bottom. You'll see why. Root k times root k plus 1 And why are we splitting the third on the bottom? Cancel, 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 that's why. So then we're left with 1 over root k minus 1 over root k plus 1. Now that's much easier to deal with. So if we go back up to the top, here we said k equals 1, k equals 2, here k is 99. So let's rewrite out p using what we just discovered to be the general term. So we have 1 over root 1 minus 1 over root 1 plus 1, which is 2. That's our first term. Let's write our second term, plus 1 over root 2 minus 1 over root 2 plus 1 is 3. Then we had a lot of this. And the last term, 1 over root 99 minus 1 over root 100. And this is just a telescoping sum. So this term here cancels with this term would cancel with something in here. So you have a minus first, then a plus, minus first, then a plus. So minus first in here, there would have been a minus 1 over root 99 in here. And that would cancel with 1 root 99, which leaves us with 1 over root 1 minus 1 over root 100. Take the principal root of 1 and 100, so that's 1 and 1 over and 10 respectively. So 1 over 1 minus 1 over 10 equals 9 over 10. And that's this interesting looking third, simplified down to 9 over 10. Nice simple fraction. Neat.